Okay, let's start. Hello, everyone. Welcome to TRON Core Devs Meeting. This is meeting number 8. Let's get started from the agenda. So first one, Zachary will introduce the latest update from java-tron. After that, Xin will give us a detailed introduction of TIP 62 and TIP 64. With these two TIPs, we will have a clear understanding of the TRON consensus. So first, hello, Zachary. Are you ready to take the first part?
Yeah, sure. Can you hear me, Ron?
Yes.
All right. So this time, mainly there are two contents this time for our upgrades. The one is we're releasing the Great Voyage 4.0.1. This time we've optimized the upgrade mechanism of java-tron. And for now, the 22 super representatives are required to upgrade to the new version instead of the formal 27. I think this will lead to more decentralized governance. And the other thing is we launched the 40 voting request today for proposal 39. And if this proposal comes to effect, zero knowledge proof verification functions will be supported in TVM. And also shielded TRC20 contract will be supported in TRON network. This will provide better privacy for users as they can hide their transactions amount, source and destination addresses. And if you want more details about our shielded TRC20 contract, you can refer to TIP 135 and 137. And also you can check our Medium and Developer Hub for more details. Okay, that's from me. Thank you, Benson.
Okay, thanks, Zachary. Do you guys have any questions on this part? Okay, if no, let's move to the second part. So Xin, would you please start your part?
Okay, sure. So can you guys look at my share screen?
Yes, I can see it now. How about others?
Okay, sure. So, hello everyone. So my name is Zing. I'm a software engineer at TRON Foundation. So today I will give a speech about the TRON consensus. So welcome everyone to join this meetings. So yeah. So for this speech, I will break part into mostly like two parts. So the first part I will talking about the older TRON consensus. And then the next part, I will talking about the new TRON consensus. We call it is a T-pose. And so let's get started from the first part, the old TRON consensus. Okay, so a lot of people when you
sorry, Xin, could you please enter the play mode?
Okay, sure. Okay, so what's consensus in blockchain? So when you go outside, hang out with your friend, or ask any other, so do you know what about blockchain? So not people know nothing about blockchain. So something like, oh, it's like decentralized, or some people doing distributed network. They also it's like something like distributed network, and a lot of people say the data people say, oh, we need to keep data consistency, since the transaction need to be validated, it need to be consistent always. So in blockchain, what is consensus? Mostly is like we want a keep a consistency for the transaction, which means even if once a transaction was being made, it need to be validated and approved by the whole network, so that we know the value of this token or the value is be proved by everybody. It's not like we do not need bank, so it's decentralized stuff. Yeah, so let's go over some the consensus algorithm in blockchain. So right now, the first one is very popular. It's like a POW, which is a proof of work. It's widely used in the Bitcoin and like Ethereum. So mostly, basically, it's like POW is like to proof of capability of. So it's like they do a while loop or something to find a validate hash value. So which start from 0, like they start from 0. So this is validate hash value. It can be like it can be very long, it can be very short. So it depends on the how it depends on network. They will give you a factor like, oh, hey, I want to like start from A0, so 10. So the first turn character should be 0. So it will take a lot of time if you do calculation. So this is the way we for the bit mostly for the POW. I guess you guys have a background about blockchain, so I'm not talking much more about detail. So the next one is the depose and the post. So these two I will cover. I will give much detail for the next slide. So the lastly is like a PBFT. So it's also is widely used in the blockchain, but it's not. I guess that's few chain use PBFT right now. Yeah, and then so the consensus in TRON. So I mean, this is all the consensus. We have TIP62. If you guys have times, feel free just checking TIP62. And then if you have any question, you can leave a comment, something below that. So let's get started, how it works. So I will give you basic summary about how it works for all the TRON consensus. So basically, it's like they have 4 stages. The first one is like vote, and then like people need to vote and candidates. And the second one is like we need to produce block. Then the third step is like we need to confirm when they finish finish block. We need to confirm this block. The last one is the reward. So like users can get reward, the witness can get a reward, the SR can get a reward. Everybody happy, yeah, right? Okay, so let's get started with the first stage, vote. So how for the vote stage, we have 3 processes we should do. So firstly, for the users who have like a TRON link or any other TRON application, they need to freezing their TRX. And after that, they can start to vote for the SR candidate. So you can go to the TRON scan or TRON link. They have a list of SR candidates. Then you can select. Then you can click vote. Then after that, the final step, we need to calculate and vote and choosing the SR. SR is not SR candidate. So in TRON network, we have top 27 SR. So it means always top 27 with the most number of vote can be SR. So yeah, from SR candidate to be SR, which means they have the right to producing block. So the next step I'm talking about is producing block. So this part is a little bit of tricky. So it's like we need to check turn. So yeah, I know other blockchain maybe have this not mechanism to check turn. And then the second step is like we need to produce the block. Then lastly we start broadcast block. Yeah, super easy. Yeah, and then so we will take a look at this picture. Turns very important. And then so for the voting stage, we getting the top 27 SR, and then based on that order, we can getting the voting order by the number of vote SR candidate get. Like we from the top high list vote, number 1 all the way to the 27. So this is the vote we get. And how do we mapping this vote to the slots index? So basically we start from the Taiwan, and then the Taiwan always start from the highest. I mean, it's like number 1 candidate with the highest vote, and then we goes 2 and 3 all the way to the 27. So each slot is 3 seconds, which means in the first 3 seconds, the the one with the highest vote start producing block, and then the next one all the way to the 27. So what happens 28 is like 28 model loop 27. So it's like the start from the number one SL. So we always do this kind of circle. It's like from the 1 to the 27 always. It's like, yeah. And then, so any question for you guys for this slides?
Yes, I have a question. My name is Philip Haslam. I'm with Simba Cash team. How do you select who among the 27 produces the block?
How do I select 27 SL, right?
So perhaps I'm confused, but you know, from what you explained is that there is one person, one super representative that produces a block.
Yeah,
How do you choose that one super representative?
Okay, sure. So how do I choose super representative? So we noticed that they have a maintenance threshold, so green, right? The green. So in the maintenance threshold, what we do is like we collecting the vote from the users. So the first one, like we say, like we have 100 SL candidate, right? So a lot of users in the network, they're voting for those candidates. And then in the maintenance threshold, we were collecting the number of vote the SL candidate receive from the users. Then we sorted by the number of vote. The SL candidate with the highest top 27 votes can be SL, right? So from a SL candidate to be a SL to be super representative. That sounds good. Hello?
Yes, got you. And once you've chosen the 27,
yeah,
which super representative would then implement a block?
You mean so you mean
block?
Yeah, produce. Oh, so basically they're producing block based on the order, and also on the select index, and also on the time. Like we start from time 1, right? And then after 3 seconds, it's time 2. So I give you like, we have 27 from 1 to 27, right? So we have this 27 SL, right? And also we have a time. We have timeline from 3 seconds, 6 seconds, 9 seconds, right? So like on the time, I say, give example on the time 3, like on the, it's like 9 seconds. At this time, 9 seconds minus 1 divided by 3 is equal to 3, right? So they get the slot index is 3, and then he will check, is my turn or not? If this is his turn, then I start produce block. How do I check my turn? It's like right now the current time slot index is 3, so my order is 4, so it's not my turn. But if my voting order is 3, yes, my turn. So I stop from producing block. Yeah, does this make sense?
Okay, so it's what I hear you saying is that it's each person gets their own turn within within the 27. They each get a turn in a linear way to produce a block.
Yeah, I'm not. Yeah, okay. I'm not sure. I cannot do whiteboard stuff. If I can do whiteboard stuff, I will give you some using case about it. Yeah. So basically, it's like, yeah, you can just like understanding like in the first 3 seconds, then the number 1 SL produces block, and the next 3 seconds, the number 2, all the way like that, all the way to the 27. After 27, then 1 to 27, 1 to 27, yeah, all the way, something like that. It's like you do a model loop from 1 to 27, and then 1 to 27, 1 to 27. Always start. It's like a clockwise. clockwise. Yeah.
Yes, thank you.
Okay, yeah, no problem. So yeah, so one thing I need to mention, so the red color is like empty. So sometimes something will goes wrong, like like the number 4, as I'll say, it's my turn. But right now, something goes wrong, I cannot produce a block. So at this time, this can be empty. It means nothing got from this period of time. So the number 4 slot, no block produced. So this is the meaning. Yeah. So we'll go over to next slide, like so as producing. So in the producing stage, we need to do package the validated transaction, because we need to validate transaction, right? So every transaction need to be validated by the key of the SR. So, and after that, we'll check. We need to switch fork or not. If we do yes, we just switch. And finally, we sign the block, and then update the logging database. Yeah, this is a producing process. So any also this so lastly we can do to confirm. How do we confirm for the old consensus? So basically we need to like a majority consensus. So I will so the yellow represent the solidity state. The red colors represent the unconfirmed block. So it's like a window size. It's like a slide window. So the slide window size start from the 1, and then always to the 19. Once we reach the 19, which means it's total 19 unconfirmed block, then we can confirm the first unconfirmed block, like the block state you can see in the second row. So the S can be a solidity state because the slide window size reached 19. And then after that, we moving the slide window one by one. Like, so if there's some, if a fork, something happens, we need to restart slide window from the 1 to the 19. So any question for you guys for this slides?
Hi Shing, this is Vinod. I have a question for which I would like requiring an answer. It might be a hypothetical situation, but
Okay.
if you can help us out with that one.
Okay,
Take an
sure.
example. You are the 27th SR, like, okay,
Yeah.
you are the 27th SR sitting with 300 million votes. Okay. And then we have Benson who's sitting with 290 million votes. However, he's on the 28th SR, and that's why he's not eligible to produce any block.
Yeah.
However, the situation remains the same for at least a month, but out of the blue moon, Benson just received 10 million votes from someone, pushing him to the 27th place and dropping you from 27 to 28. So might be Benson was not ready with his equipments to produce the block. So in that case, what exactly will happen? Because now Benson has moved to 27, but he's not like ready to produce the blocks. So he hasn't prepared himself in the past. So will it be like 26 SR producing the blocks in that case?
Oh, so I just tell you. So we have apples. Sorry, so we have a definition about apples. So one apples is like 6 hours. Every 6 hours, we select the SR. So after next 6 hours, Benson will start producing block. Within 6 hours, the SR cannot be changed anymore. Cannot be changed. It's like, oh yeah, Benson just top 28, and then next 10 minutes, Benson, top 27, but it doesn't work because within 6 hours, the Benson cannot produce a block. After that, then we reselect SR. This is the way how TRON works. So it's like every 6 hours. Yeah, for SR.
I do agree. So Shing, I do agree. It's 4 times a day. I do understand. What I'm trying to ask here, what if Benson is not able to, sorry, what if Sheng is not able to move from 28th back to 27 in those 6 hours? What if there's no more 10 million votes coming in? Like, do we have any type of grace to take care of this thing, or we will end up like for maybe for the next 8 or 10 hours we will end up like getting blocks produced by 26 SRs rather than 27 in total? So it's just a hypothetical situation that I'm asking. It might happen, it might won't happen anyway.
Oh, wait. So so I have a little bit confusing about your question. So your question is like the vote stuff, right? So the Benson can getting the vote, 1 million vote after 6 hours, right?
Yes, after receiving votes, say it is now 8 hours since he has received those 10 million extra votes, and the person who dropped from 27 to 28 haven't received any new, or say roughly 10 or 11 million votes in those, say, more than 6 hours. The cycle has passed. The 6-hour cycle has passed. So now you need to get the SR in the list.
We do not change the same. Once we selecting the SR, we do not change within 6 hours. Yeah, whatever you do, whatever, maybe network you issue, something goes wrong, whatever, stay the same. We do not care about special case. So just within 6, yeah. Because some sign-ups can be in a lot of country where the network is bad, something. So we cannot take care of this. Yeah. So yeah.
Got it.
So any question for this confirmation? This part. If not, I will move into the next slide. So I would like to mention that why do we choose second, third plus 1? It's like not half plus 1. It's like if we choose half plus 1, it's also majority consensus. But in this way, we can give example like we have 11 nodes, 5 good, 5 bad, 1 and 1 is down. So in this case, we cannot reach agreement. We cannot reach a consensus. So this is where we choose second, third plus 1, because the third is odd number. It cannot always be equal something. Yeah. So what happens if there's some fork? So in all the TRON consensus, we always choose longer chain as the main chain. So which means every time you just checking the size of the chain, and then if the other chain A in your local database or something, if you find any longer chain, you just switch and then broadcast. So this is it says like a majority consensus. So if hacker control most of node in the blockchain, then everything is fucked up. But the likelihood of this can rarely happen because the hacker cannot take control of the majority of the node in the TRON network or other blockchain network. This is something like depose. Yeah, every depose is working on this way. Yeah, they assume the hacker cannot take control of the majority of the node over the network. So the next slide is the reward. And in our TRON consensus, we have a very good policy for the users and then witness. So the users who give vote to the SR, they can receive a reward, and the SR which producing block can getting their reward also. Yeah, so both sides can benefit from our network. So yeah, we can. So, but however, there are a lot of limitation for all the TRON consensus. So we start to do some optimization for our old consensus. Like for the original old TRON consensus, like it always take too much time to confirm a transaction. Something like 1 minute. We need to confirm a transaction, which is not so good. Take a look at the like Ethereum on other blockchain. They always like some something like 3 seconds or 10 seconds, especially for the users who want to finish a transaction. If let the user waiting a minute, it can be not torrent. So we need to start optimization. This is not good. And also for the exchange, the app, wallet, especially for the real-time transaction, for gambling, for the game, we need to fast blockchain. And then for the other big project like cross-chain, we also need to sign good consensus to support blockchain. So in all of those, our engineers start to brainstorm, like how do we choose for the next voltage? Like that Bitcoin is like we choose Depose or PBFT or others. So take a look at this picture. POW is very slow. It's very slow. So no. Then Depose, yeah, Depose is good, but we want to get more perfect. So then we it's like we can take a look about the PBFT. This is currently this is very fast. The fast consensus in the blockchain. So we just pick up the PBFT for our TRON consensus, and we do some a little bit of modification for the previous PBFT. I will give you an introduction about the second part. It's a Depose. It's TRON consensus algorithm. It's part of a PBFT with Depose. So if you guys have interesting, you can check in the TICP1 in our TRON GitHub page. So let's get started. So I will mention about the role. So for the PBFT, we have primary replica and the replica and the client. For Depose, we only have verify SR and the full node. It's totally different. Right? And then talking about phrases, in the PBFT phrases, we have 5 phrases like request, prepare, and prepare, pre-prepare, commit, reply. In the Depose, we have only 3. Like we have block broadcast. It's like they equivalent to the prepare in the PBFT, and then we have voting stage is equivalent to the prepare, and lastly we have verify equivalent to the commit commits in the PBFT. So this is how PBFT works. So basically, a client will send a request to the network and to the primary replica. Once primary replica receive the request from the client, then it will broadcast the message to whole network. And then once the other replica receiving the message from the primary replica, they will multicast prepare message to the network. And then again, on the prepare stage, once they receiving the message from the pre-prepare stage, and then they were studying this commit. They will start to generate commit stage, commit message, and then they will multicast commit message to the whole network. And then after working the same way as prepare, and then they will send to reply message. And then on the client side, if the client receive the second, third plus 1 a message from the replica, it will confirm, oh, this message is good, and then nothing happens. So if the number is less than second, third plus 1, it means something goes wrong with the network. The data can be modified, or hacker can be take a control of some node. So this is how PBFT works. So basically, what if the like primary is done? So the PBFT, what does PBFT do? Is like they will give a view change, and then they start to do 3 PC consensus. So at the first stage, primary gets done, and then all of those 3 reselect primary replica, and then they increment the TCP number, and then start the same process that I mentioned before. And then for all of the replica, they always accepting the message with hiding TCP sequence number. So which means the older primary call which was done will be abandoned because they always receiving the TCP number with the bigger sequence number. So they were choosing the new primary replica, and on the prepare and commit stage, they also require to receive a second, third plus one the message from the previous states. Yeah. So this is how it's working on the PBFT. On TRON, they are a little bit different. We just have 3 stages. So like for the SL, once SL finish producing block, they just broadcast, and then a lot of SL in the network, they will receive the. Okay, I will give you detail about next slide. So basically on the TRON depose, the client, the client and the replica are all SL in TRON. So you can take a look at these pictures. So no client in the TRON depose, and also like the replica is the same as SL in this picture. So we do not need to request, and also we do not need to reply. We just need to three stages. We can reach consensus. So how it work in TRON? And then so in the first step, an SL start producing block, and after they broadcast this block to the network. Then in step 2, the SL, we also call it verify because they use for different function. The verify start to validate block, and then sign and multicast prepare, and sign and multicast this message to the over the network. And then on the step 3, they will validate the signature and the multicast the commit stage. And then after that, the SL, you will check whether he received second, third plus one verify commit message. If yes, then they will make this block to be selected state. So it's like in S3, and he receiving the second, third plus one PBFT commit message. So this S3 can setting to be selected state, and then all the block ahead of S3 can be also to be a selected state, because the hash value and the block have dependency on the hash value, which means the hash value of S2 depends on the hash value of S1. So take a look at the S3. So all the way goes to the S1. So if we can confirm S3 is the validated state, it means S2 and S1 can be validated. So this is the way how to work for our depose. So any question? Any question for you guys? Oh, if no, so okay, go ahead.
Please continue. I say.
Okay, sure. Okay, and so how we handle fork? We have 2 rules. The first rule is like the first receive. So whoever receiving the second, third PBFT message, they can confirm block. Then the rule 2 is like always choose a longer term. If any node receiving second, third PBFT message, at this time we always choose longer term. So it's pretty much the same as like depose. We always choose longer term, but at this time we also need to choose to first receive. Why? Because right now we are PBFT trend. So it means we always accepting the PBFT message first. So take a look at this case 1. And we have fork here, but on the time 2, like the U plus, the second U, we're receiving the second, third plus one, the PBFT message. So we were choosing the second trend although it's short, but we always choose a chain who always first receiving the second, third plus one PBFT message. So it can be the main chain right now. So take a look over here, and then the second rule is like, take a look at these pictures. If we do not receiving the second and third plus one PBFT message, and then what happened? We choosing longer chain. And also, if we do not receiving like U, the red U and the green U, they're receiving half plus one or half. So cannot reach agreements. So we still the second U, the first U and the second red U and then the second green U always, and then we switch to the longer, the first one. But if they but at this time, if any of this chain receiving the PBFT message, we will switch to the the chain who receiving the PBFT message. So any question for this rule? I know there can be a lot of questions for this. Hello? You got any question for this part?
So I got one question. So yes, just you mentioned that the first rule have a higher priority compared to the second rule. So can you switch to the second rule page?
Yeah.
So you mentioned if we cannot get enough PBFT message, so we will choose the longer chain as the main chain, right?
Yeah, absolutely. Yeah.
Yeah. If you just mentioned, if you finally got another block which has enough PBFT message, does there any chance that it will jump to the other chain as a main chain?
Yeah, probably like at the Taiwan, we choose the first red chain, green chain, and then but what happens next time is like, oh, the green chain receiving the PBFT message, so you will switch to the green chain next 3 seconds or something. Is yeah. Oh, you was so it's like you start from the longer chain and then you switch to the short chain, but the short chain is seeing PBFT message. So this is the way how we work. So, right. So that this answer is good for your question, or
yeah, somehow I need to look more because okay, please continue. I think I'm okay.
Yeah. So this is the way we work. Always follow this rule. And for the priority issues, we always choose rule 1. If not, then rule 2 always. And then this is the way how we do for fork stuff. Yeah. And then the performance issue is very interesting part. So the all the TRON consensus, they taking 19 slot time to confirm a block. Also, it's like the confirm transaction, which like approximately 1 minute. But for the PBFT, for T-pose, we only take 1 time slot for in theory. Yeah, this is like we have 19 times performance improved. So if you guys have interest in that tracking TIP 16.4, and then we just give it a little bit proof. So take a look at the case 1. We receiving a commit message within the one apples, right? For the case 1. So for F, so we need to verify something. The producing order is like A, B, C, D all the way to the end. So the receiving order can be different for different witness. Some witness the network is good. They can receiving order. Some witness the network is not good. It's bad. Oh, they were receiving out of order, right? So like case 1. So the order of the receiving block is like C, B, H, F. So at this case, in the time of F here, if he receiving the second third plus 1 PPFT commit message, then they can confirm 1, 2, 3. Let me see. They can confirm 5 block. They can confirm 5 block. So it's good. And if you do a math, it's still O1, right? O1 average, because from B to F, they have like 3 plus 5, 15 seconds. And then the time of F, like at the time of 15 seconds, we confirm 5 block. So on average, 3 seconds, 1 block. So this is the case 1. For the case 2, for case 3, yeah, which is good. We're just receiving commit message with 1 slot time. Yeah, this is expected the result we want. And then A and the B, so B, yeah, we follow the producing order. We just like we're moving the slide window, follow the producing order, A, B, C, D, F, G. Yeah, we just confirm A, confirm B, confirm C. Then we go this order. And so what about the worst case? We take what happens in worst case. So worst case for this part, like we cannot receive a message. Like for this part, A all the way to the S. Oh, we cannot receive it. Like the order is like reward order is like a case 2. The receiving order is like S, R, Q, P all the way to the B. And then lastly is A, it's another A. So in this case, although it's rarely happens, but still we get O1 on average confirm time. So you just take a look. Even if we have 20 or 100 block, it's unconfirmed. But on the next slot, if we got the second, third plus 1 PPFT message, we can confirm more than like 100 block. So still O1 average, right? But this case rarely happens. The probability of this case rarely happens. So yeah, we just give you some proof. And so take a case 1, 2, 1, 3, 4, and here these pictures. So we in theory we can get O1 slot time to confirm transaction, even if the network is bad. Yeah, this is very good comparing to the other TRON consensus. So if you guys have any interesting about the proof, just checking the TIP 64, and then I have to little bit of math about it. Yeah. Yeah. Okay. So oh, sorry. This is another for proof for switch fork. So if we have fork, we cannot reach an agreement. The same, we just take another O1. It's like O2. Yeah. If always the two chain do not have like a red chain and a green chain cannot receiving PPFT message always until one time, yeah, these two compete with each other. So it's like O2 average because we have a fork issue need to be considered. Yeah, but still it's like much better than all the TRON consensus. It's like 6 seconds. More than, it's much better than 1 minute. Yeah. So any questions for you guys about this part or something?
What is the hello?
Yeah, I can hear.
What is average confirmation time for one block? 3 seconds?
Yes. Yeah, O1 slot time. Yeah.
Okay, that's pretty fast.
Yeah, you just can check because it's not like we confirm block 1 by 1. It's like, oh, we start from the time 1 and then take a look at this picture, or they have huge block. Oh, like some guys say, I'm producing 100 block. Why do you confirm anymore? And then they have 100 on the list as unconfirmed. But at the next 3 seconds, I confirm 101 block total. and then, oh, she's happy because at this time we confirm 101, and on average it's 01 for block producing time. It's not like all the Tron consensus. We're waiting for 19 block time to confirm transaction. Yeah, so this is much fast. But on this case, it's rarely happens. The network issues or something. This is the working case, just for mathematics to computation something. Yeah.
I would say it's a huge improvement. So can you also introduce some possibility based on this improvement?
Yeah, sure. Yeah, this is our future plan. So the TICP1 is like simple proof, verify. So we have a PBFT message. Inside the PBFT message, we have a style signature and the next style is list. I'm pretty sure we have a meeting about this part. You guys have interest in just checking our GitHub page. We have TRON Devs meetings about this part. Yeah, so this is the implementation of a PBFT T-pose because we have SR signature, so we can do a Wally SPV, which means you can get in the block header. It's Wally light block header. Then we can do Wally fast simple payment. We just getting the hash value of transaction. Then we get in the block. We finding the block, the hashing Merkle root. So we just compare if the Merkle root is the same or not. Then we can verify this transaction is validated or not. Yeah, this is the way how SPV work. So firstly, basically it's like they got for a transaction A, I need to know which block. Then they get the block, and then they calculate the Merkle tree root, and then I get Merkle tree root hash value, and then I got the I got in the Merkle tree hash value associated with this transaction by query the blockchain, and then I get once I receiving a block header associated with the this transaction, and then I can get in the Merkle tree root hash value. Just compare equal, validate, not equal, invalidate. So simple. So yeah, this is the implementation for the Tron consensus. We put in the SR signature and the SR list. We can for those two we can be ensure the correctness in a block header because so just if you guys have interest in just in checking the tip, yeah, it's working the same way as the T-pose, yeah. And then the second future plan is like cross-chain. How we do cross-chain, because for chain and chain B, we communicate with the PBFT message inside in block header. So right now for the Tron block, they contain the PBFT message inside the block header, which means they can use for the cross-chain function. It's especially like if this chain use PBFT, yeah, it's very good. If not, we can also do some little bit of mapping for the block header. So this is the other implementation for the Tron consensus. Yes, cross-chain. This is also is ongoing project inside the Tron, and right now we have a team, a lot of engineers working on this project. Yeah, it's pretty much pretty much good, awesome project because this is the future. A lot of crypto company working on the cross-chain. Like, yeah, because the user do not want, because right now now there's so many cryptocurrency. Like I have TRX, I have Bitcoin, I have ETH, I have so many. But if you can do blockchain stuff, yeah, I can use TRX by Ethereum, Bitcoin, or they can do mutual verify. Yes, very good. And then lastly, would like to say for the performance optimization. So in theory, right now it's like we can do a 1 slot time, but something goes wrong. Is like the signature or the block header is too heavy. We want to make it light, so we will improve for the signature, make it a lightweight signature. It's like reducing the bytes of the signature so that it can deliver very fast among the network, and also for the network transfer, we can do a little bit of optimization for the transfer, like protocol stuff, so that we can get faster transfer, get lighting block header. Say, yeah, this is, yeah. So any question for you guys? Yeah, this is pretty much I was talking about for today's topic. So any question for you guys?
So do you have any plan when will Tron launch the cross-chain project?
Cross-chain? I'm not sure. So right now, our team is working on the cross-chain project, some feature of cross-chain. Yeah, but I guess 4.001 have some feature of cross-chain, but we do not finish yet.
Okay, thanks. Okay, is there any, thanks team for sharing. Is there anyone who has any other questions before we cut off? Okay, if no, I think we can end our meeting now. So the next meeting timeline and agenda will be updated on GitHub after confirmed. We'll also keep you updated in the Telegram channel. So thanks everyone for coming. Thank you. Bye.